So are sunglasses actually bad for our eyes? I've seen numerous influencers across the internet claim that sunglasses are actually making our eyes worse, that they are increasing our risk for sunburn, as well as having other negative health effects. And I'll be honest, as an eye doctor, my initial thought to this was never. This is complete BS. I've never seen anything supporting these claims. Well, I have spent an embarrassingly huge amount of time researching and basically finding what I consider like the edge of medical publications on the internet. And I finally found something. I found several publications that in fact might support this hypothesis. And I'll be honest, it is changing the way I think about things. So in today's episode, I'm going to be breaking down this research, addressing it, and making sense of where it takes us. But first, let me just welcome you to the Dr. Eye Health podcast. My name is Dr. Joseph Allen, and here we not only help you learn about the eyes and vision, but help you optimize and take care of your overall health and well-being. Now, if you are in that 90 to 93% of people who have ever watched or listened to our podcast and have gotten value from it and have not hit that subscribe button, please consider doing so because one, it is absolutely free, and two, doing so will remind you and let you know when our next piece of content comes out. So really, it's a win-win for everybody. Now, before I start diving into this research that I found that supports this idea or concern that maybe UV light could have a positive benefit for our eyes, for our health, for our skin, I do want to kind of talk about why sunglasses historically have been recommended by eye doctors, dermatologists, researchers, like where I have come from historically. So sunglasses mainly have three benefits. Bottom level, they're for fashion, they make you look cool. The next level is that they offer some reduced light transmission, right? It helps kind of filter out and make the eyes more comfortable. They reduce glare and they can improve visibility, right? That's why sunglasses are often worn inside the car when the sun is just in that perfect spot that bothers you. But also, in fact, if you remember, Ray-Ban sunglasses were first invented by a collaboration between Bausch & Lomb and the US military because they wanted a sunglass that aviators could use that not only helped them see, but also would help reduce certain types of glare that they would experience while flying. The kind of most important benefit of sunglasses and why eye doctors often recommend them are because they have environmental protection benefits. You basically are wearing a shield in front of the eyes that blocks out wind, debris, but also blocks UV ultraviolet light. And again, that is the main reason why eye doctors, dermatologists, and other health experts recommend sunglasses. Repeated high levels of UV light exposure is associated with many risks to the skin, the ocular surface, and even risks to some eye diseases, such as forms of cataracts and age-related macular degeneration. Now, if you ever go to the beach and spend time near water without sunglasses on, and it's a day with high UV light index, and I'll share that it doesn't have to be sunny out. I have gotten terrible sunburn in my life because I went out on a cloudy day thinking it wasn't that bad, it wasn't that hot out, but in fact, the UV light does pass through the clouds. And if you, again, have spent time at a pool like this and not worn sunglasses, and several hours later, you may feel that your eyes are gritty, they're irritated, or maybe look red. And this is actually due to sunlight exposure and ultraviolet light damage. Basically, you have sunburn on the eye. People who even ski or snowboard at high altitudes without eye protection on, without goggles, or again, people who are at the beach around water, they actually get hit with UV light even more because UV light will reflect off of snow or water surfaces. It's like 85% of the light will reflect. And then off of even beach sand, it's like 15% of reflection. So you actually get kind of hit double whammy when you're in those environments. And When you get sunburn on the eye, we call that photokeratitis. We even see this for people who aren't around sunlight, but get them from kind of other sources, like welder's flash. It's the same sort of type of UV light that hits them in the surface of the eye, and this can cause the same type of photokeratitis. And it's very painful and irritating. This exposure to sunlight also increases the risk of growths on the eye, such as pinguecula and pterygium. If you've never heard of these terms or not 100% sure what those are, if you ever go to a place that's close to the equator, especially a place that gets a lot of beachfront and sunlight, again, closer to the equator, they get more UV light radiation. And you may notice a lot of people will have kind of a pink or flesh-colored spot growing on their eye around 3 and 9 o'clock on the eyes. And that is due to irritation and largely from UV light exposure being like a major contributing factor. And when you get that damage, basically this sunburn on the eye, it creates a hyper-inflammatory response that kind of contributes to the growth of this kind of fleshy-like tissue, because the eye is basically building up a callus. That's the way I like to think about it. It's building up like a callus to try and protect itself. Now, in addition to all of this, ultraviolet light exposure leads to photoaging of the skin, right? It leads to early signs of crow's feet and wrinkles, in addition to a higher risk of skin cancers. Now, of course, I am not a dermatologist, but depending on the study that you read, I have read that it's estimated up to about 90% of skin cancers are related in some degree to UV light radiation damage. Okay, now I'm going to get a little more eye nerdy here about UV light penetrance into the eye, because I think it'll all come in later when I review these studies and the claims around UV light and sunglasses. So first, understand that there is ultraviolet A or UVA, there's UVB, and there's UVC light. UVC light is potentially the most damaging UV light, but thankfully UVC doesn't typically penetrate through the Earth's atmosphere, whereas only about 5% of UVB light reaches the Earth's surface, which means that about 95% of all the UV light that reaches our eyes and our skin is, again, it's primarily UVA light. As a reminder, if you want to be an eye nerd too, and you want to read any of the research, anything that I'm referencing here now and about to reference, again, I'll include all of these references in the show notes for you, because I'm not making this stuff up. Again, you can read this research and all of this information. So in adult human ocular physiology, it has been found that around 2/3 of the UV light that hits the eye is absorbed by the cornea. What else that passes through the cornea then goes through the aqueous humor and hits the lens inside of the eye, which then absorbs nearly the rest of UV light. To help put numbers to this, consider a 2023 study published in the International Journal of Ophthalmology that shows in porcine test eyes, so this is pig eyes, 99.77% of UV light is filtered and blocked by the cornea, the lens, and the vitreous humor of the eye, meaning only 0.23% on average of UV light even reaches the retina in the back of the eye. And of course, pig eyes are not human eyes, but they are very similar. In fact, in training for things like ophthalmology and surgery, they use cow and pig eyes as a test subject. And many times they use pig eyes for clinical trials when doing a surgical operation for like glaucoma, for example. An interesting note is that the biggest concerns of UV damage to the internal structures of the eye occur mostly in our youth. This is before the age of 20 years old. And this is because of the aging and thickening of the crystalline lens inside of the eye that comes with age. Along with the size of the pupil is usually much larger in young kids. This has to do with our sympathetic nervous system. But that means young kids, their pupils are larger, and again, they have a thinner lens inside the eye, so light penetrates deeper into the eye, and their lens isn't able to absorb as much of the UV light, which is a strong support for why young kids are recommended to have either sunglasses or a wide brim hat to protect their eyes from harsh sunlight when they're playing outside during the peak UV light hours of the day, which is usually between 10 a.m. and 4 p.m. So now that we have reviewed why doctors and experts have recommended sunglasses for so many decades, let's talk about this internet trend and some of the claims around sunglasses being bad for the eyes. Now, I've found many social media influencers making these claims that wearing sunglasses could in fact cause you not to tan and cause worse sunburn. Now, almost every post I could find online never cited research or evidence of where they were getting this information. However, I did come across a few podcasts online that had the guest Dr. Alexis Cohen, PhD. And on various podcasts, I have heard her reference research suggesting that this UV light is extremely beneficial, not only for our skin, but specifically for the eyes. So after digging and finding some of her academic lectures online, I was finally able to find a reference to some studies. Most of the publications that I'm going to be reviewing here, they stretch mostly from back to the early 2000s and 2010s, and they're all using mice models. But they did report some interesting findings. For example, back in 2003, from the Journal of Investigative Dermatology, the lead author, Hiramoto, reported that ultraviolet B radiation to the mouse eye activated a nitric oxide-dependent hypothalamo-pituitary pro-opiomelanocortin pathway and modulates functions of alpha melanocyte stimulating hormone responsive cells, which stimulate melanocytes in the skin. I know there's some really big words here. I just want to be certain that I'm quoting it correctly, but this is a very higher, more in-depth topic that perhaps we'll even reach out to this author and see maybe if we can get some better explanations. But later publications from this same author also found that these same pathways connecting the eyes through communications to the brain and other parts of the body found that these pathways also play a role in immune and possible metabolic functions within multiple tissues in the body, including the skin and even the GI tract. Now, these studies were mainly conducted by shining a UVB light into a mouse's eye by using a sun lamp. Basically shining a sun lamp directly onto the mouse eye while covering the eyelids and all other tissues of the mouse body, either in tinfoil or using a very strong type of sunblock, like on the eyelids of the mouse. Now, a 2009 Journal of Dermatology, same author, they reported and found UVA light also triggers a similar pathway that downstream stimulated Langerhans cells, which are an immune cell found in the skin. Interestingly, the author also reported that they were able to identify that these signals coming from UVA treatment directly to the mouse eye communicated through the optic nerve. Again, UVA treatment to the mouse eye sent signals through the optic nerve. However, the publication from 2003 that I had previously referenced, in fact, reported that UVB light, again, different type of UV light, but UVB light triggered communication to through the brain and through these structures, but not through the optic nerve, but instead through the ciliary ganglia involving the first branch of the trigeminal nerve, which I think makes some physiological sense because most UVB light doesn't penetrate deep enough into the eye to even reach the retinal photoreceptors to deliver a signal through the optic nerve. Now, while I think it's reasonable to find this information super interesting. And I think it's easy to jump to conclusions that based off of this, that perhaps UV light could be perhaps a good thing for the eyes and the ocular tissues. However, I do also think it's important to highlight the same author and that they reported this. So in 2012, in the Archives of Dermatology, they reported that UVA light, again, directly to the mouse eye, similar study design, but through the same neurological pathways mentioned, was responsible for photoaging of the skin. So a few years later, they reported that these pathways also trigger the body. Through the eye, UVA light helped enhance the photoaging of the skin. In addition, a more recent publication in 2020 in the International Journal of Biological Sciences, they found that long-term UVA exposure, again directly to the mouse eye, also compromises learning and memory in mice. And they studied this over a full 12-month period. So while there seems to be some preclinical or mechanistic evidence that UV light exposure to the eye could have some sort of consequence or health benefit, there's also evidence swaying the other way. Now, there are some big things all about this research that I think we do need to air out. First, these are animal studies in mice, not humans, right? And the last time I checked, mice are very different than humans. We don't know if this information, this type of research will also reflect to the human physiology. Many of these studies in this space have been led by just one lead author, right? And in the research space, we do like things to be corroborated. So hopefully at some point, this will be duplicated by another research team. And then finally, these studies, while they do help identify a possible mechanism, this doesn't necessarily prove meaningful significance. Meaning that even though there may be something going on biochemically, biophysically, it doesn't mean it's going to make a clinical or meaningful significance outside of a laboratory in that exact type of scenario. And this is where I admit that before stumbling on this research, I was honestly very negative and naysay about all these online trends because I simply thought there was no research behind it. And honestly, it was not easy to find. Myself, and I know most doctors, whether they use something like Google or even use AI to try to find research articles, or myself, I spend a lot of time in PubMed. It was very hard to find these. Most of these publications are not in eye or vision care journals. They are in a little bit more obscure, like dermatology research journals. But while I found all of this information in these publications interesting, I've spent many hours pondering this, and the reality is I just have not seen enough evidence to overrule the recommended clinical guidelines set forth by the American Optometric Association, the American Academy of Ophthalmology, or the American Academy of Dermatology. We have overwhelming evidence with numerous diseases aggravated by UV light exposure to the skin and the eyes. So at this time, I will still recommend sunglasses and wide brim hats, especially for the best UV light coverage, and especially during the peak UV light hours of the day, again, between 10 and 4 p.m. And if somebody doesn't want to wear sunglasses, right, they don't like the tint, the darkness of the sunglasses, they can also consider clear lenses, such as safety lenses or even just regular glasses lenses that block UV light around the eyes, or again, consider a wide brim hat at the very least. But bottom line here, I think from reading all of this, it's clear to me that there is at least some mechanistic evidence in mice that perhaps UV light does trigger and alter some biochemical pathways in our brain and through our body that may be positive and supportive, especially for trying to protect our body from things like UV light damage. However, it's tough for us to make a claim and know exactly where that nuance begins and ends, especially for meaningful human health. right? We don't know how much. Is this going to make a less than 0.001% difference or not? So at this time, still, I think it's best for people to have UV light protection. Myself, when it's peak UV light hours of the day between 10 and 4 p.m., I do wear sunglasses or a wide brim hat, long sleeves that protect from UV light exposure, and or sunscreen when necessary. Now, of course, I'm not speaking for all health professionals. Again, I'm not a dermatologist, but I think it's important to consider these things and follow reported guidelines, as well as talk with your local eye doctor about their concerns and any risks that you may have. Now, I know we covered quite a bit here today, but if you enjoyed some of the deep dives into me breaking down the research, then please let us know that in the comments, or if you're listening over on the podcasting platforms, then please go ahead and leave us a review and share what you like in these episodes, because that is something we do read and take to heart. But otherwise, from here, let me just say thank you so much for tuning in. Keep an eye on it, and we will see you in the next episode.
You've been listening to the Dr. Eye Health Podcast with Dr. Joseph Allen. For more resources, trusted information, and helpful tools, visit dreyehealth.com. Thanks for joining the community that's focused on healthier eyes and a healthier life. Until next time, stay informed and keep your vision sharp.